Alright, so the last time that I saw you guys, we did this activity with perfect squares and showing that the area of a square, just one length of the side, would be the square root. So the square root of 16 is 4 because that is the side length of that square. So we're going to look today at a question about what if we're dealing with not perfect squares? How do we know what numbers are a perfect square and what numbers are not perfect squares? So looking at that, with that in mind, if you were in my classroom, I would give you a whole bunch of colored tiles and we would physically do this. So we're going to do this digitally. So we're going to use colored square tiles to make a square with an area of 16. So think of it like when you were in 3rd grade or 4th grade and you made arrays with the multiplication tables. You could make an array of a 1 by 16, like this one right here. Or you could make an array of 2 by 8. That still makes an area of 16. Or if you follow the directions where it says to make a square with an area of 16, here's our square with an area of 16. And if you count all these little squares inside there, you would see that it's an area of 16. I just erased it all. Sadness. Okay, so what is the length of the side of your square? Well, if you look there, zoom in real close, pretend it's a perfect square. Okay. So the length of the side of the square would be 1, 2, 3, 4. And if I look at any of the other sides, it's 1, 2, 3, 4. 1, 2, 3, 4. This is what makes it a square. Same length on all 4 sides. So 4 is the square root of 16. It's the length of one side. So we would write that as the square root of 16 is 4. Now that is not any new information yet, correct? We've done that. So then we'll look at the second question, which says use those same colored square tiles to make a square with an area as close to 12 as possible, but not greater than 12. All right, so look in here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I add this square, here's 10, 11, maybe 12, but there's a problem now. 12 doesn't make a square. What if I put it on the other side? That didn't work either. So no matter where I put these last 3 tiles, I'm not going to have a square anymore. I'm going to have a rectangle. So that's how we know that 12 is not a perfect square. The actual number does not make a square. So what is the length of the side of the largest square you can make? Well, what is the length of this side right here? Yep, it's 3. So 3 goes in this blank right here. All right, therefore the square root of 12 is greater than 3, but it is less than, now if I go over here, and that's the one we did in our first problem, I have an area of 16 and a side length of 4, so think about it. The area of this square is 9. There's 9 tiles here. Okay, the area of this square is 16. So we have an area of 9 and an area of 16, which the side length of that, the square root of 9, is 3, and the square root of 16 is 4. So then somewhere in here, if I had 12 and I'm trying to find just one side length of that, what would that square be? It would be somewhere in between the numbers 3 and 4. Somewhere. So it'll be a decimal or fraction of some sort. All right, so then the third question says make a square with a side length of 25. So here I've got a square. 1, 2, 3, 4, 5. It's got a side length of 5. And if you look, all the sides all the way around have a length of 5. So then what's the area of that square? The area of that square is 25. Therefore, 5 squared, that's why this is called squared, is 25. And the square root of 25, which is one side length, that would be, that's a 5. Easy enough, right? So then this next question says, what is the largest square you can make using 40 tiles? Now, what does this tell us about the square root of 40? So I've already arranged for you here a square. And if we count the area of this whole entire square, it's 36. If you count all those, that's 36. Okay, but then here's 37, 38, 39, 40. So if I tried to put those last 4 tiles up here, then I wouldn't have a square anymore. So what's the length of one side of this big square right here? What's the square root of 36? So if you count one side, you should get 6. What does that tell you about the square root of 40? Well, it should tell you that the square root of 40 is somewhere between 6 and 7. That's all we can tell at this point. Somewhere between 6.6 and 7. So 6.6 decimal something, or 6 and some fraction. If I would like the side length of a square to be between 5 and 6, what is one possible value for the area of the square? How would you know? Well, on a previous question, we talked about how 5 squared is 25. And we just had on the last question, we talked about 6 squared is 36. So if we want the side length, if we want the square root to be between 5 and 6, then we want the area to be somewhere between 25 and 36. So numbers that would work would be 26. Etc. I think you get the idea there. Any number between 25 and 36, including 25 and a half. Okay, we could also have the area be a fraction or a decimal also, or a rational number. All right, in the last question that we're talking about here, which is something that we have to work towards. So if you don't get it perfect today, that's all right. We'll continue practicing this. Is taking an imperfect square and placing it on the number line. So the square root of 14 we have over here in blue. Something I should have led with is right here. Something that I like to do for myself is say square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. and the square root of 25 is 5. So I've got 9 squares right here, and then here's 10, 11, 12, 13, 14. Okay, now if I take these and try to add them up here, I won't have a square anymore. Okay, I think you get the idea. So I'm going to take these guys away and just put them to the side, because if I put them with my square, I won't have a square anymore. It'll be some other odd shape. Okay, so what is the square root of this square right here? What is the area, or excuse me, what is the length of just one side? If you said 3, you'd be correct. Okay, so just the length of one side of this square is 3. So the square root of 14 is going to be 3 something. We don't know what. So we'll say the square root of 14. All right, now, knowing that, looking at 14, I know it's going to be 3 decimal something. So it's going to fall, and I look at this right here. 14, the square root of 14 is going to come between the square root of 9 and the square root of 16. Now, which one would it be closer to? Would it be closer to 9, or would it be closer to 16? If you answered it'd be closer to 16, you'd be correct. So we could say the square root of 14, we could place it somewhere in that vicinity. So 3 decimal something, getting closer to almost 4, which is the square root of 16. So looking over here at the square root of 8. Right here, I have 8 squares. I've already arranged them into the largest square that I can make with 8. If I add these 4 squares, I'll get really close to a perfect square. I would just need one more tile and I'd have a perfect square. I'm just missing this guy right here, but I don't have him, so it's 8 is not a perfect square. So I'm going to take these guys and put them to the side. So looking at this perfect square, what is the length of one side? What is the square root of 4? If you answer the square root of 4 is 2, you are correct. So that tells me that the square root of 8 is going to be 2 and something. Now, comparing the square root of 8 with the square root of 4 and the square root of 9, which number is that closer to? 8. Is it closer to 4? Is it closer to 9? If you answered it's a lot closer to 9, you are correct. So the square root of 8, we'll say, is somewhere in there with 2 decimal somethings. And that's all we have for today. Thanks for listening.